Me project Auto Climate Monitoring System. Team members Shantanu Wankhede, Tejas Khode, and here myself Keshav Rathod. Under the guidance of Dr. P.N. Chatur sir and Mr. Dhananjay Deshpande sir in Department of Computer Science and Engineering, Government College of Engineering, Nagpur. So introduction. The importance of climate monitoring system is existed in many aspects, like to ensure the safe working environment in warehouses. The climate condition of field can be monitored from distant place and won't require them to physically present. Time to time updating the real time situations of warehouses on web pages. Situation like monitoring temperature and humidity using different sensors on IoT. Central Warehousing Corporation, here we are developing this project for the CWC, is into scientific storage and handling services for more than 400 commodities, including agriculture produces, industrial raw materials, finished goods, and a variety of hygroscopic and perishable items. Storage loss of food grains and perishable goods are being controlled through quality control practices. So our objective is make current system obsolete, reduce human interventions, make it centralized for the whole warehouses, analyzing data based on the previous readings and real-time display of data. So now literature survey. Solution of problem include a low cost of hardware component and accurate data acquisition. Due to the cost efficiency, we can install more tools in more warehouses. The main objective of this project is the system is totally user-friendly. User can monitor the temperature and humidity at any place. Along with the feature of monitoring, added the data visualization part for simplifying efforts of users. The eye-catching part in the monitoring system is alert lamp. When the temperature and humidity of the warehouse exponentially increases and crosses to a certain limit of warehouses, it will automatically glow and alert the user. So now problem statement. Low cost IT solution preferably around Internet of Things sensor to existing application software. The sensor is expected is to capture the atmospheric moisture and temperature inside the warehouse. Based on the moisture and temperature data so captured, the software should do appropriate data analytics and send timely alert to concerned official of CWC for mitigation and remedial action arising due to the moisture and temperature inside the warehouse. So drawbacks of existing system: lack of automation in warehousing and lack of automation data to develop policies and manpower needed. So we propose the solution for the system. Like that, we are using sensors for monitoring this atmospheric condition so that the result will be accurate and our system will be faster and less power consuming, and all collected data will be sending to the ThingSpeak web server is to maintain the climatic condition of particular place can be known anywhere in the world. So here our block diagram, which is in center we use a node MCU ESP12E, that is ESP8266, and we are supplying power supply in left side and connecting the sensor, that is DST11, for monitoring temperature and humidity, and in right side we will generate a real-time monitoring data. So now system operation. Our system operation divided into a two module. In first module we will acquire the data from real time, means from warehouses. The data contains like temperature and humidity, and all collected data gathered into a node MCU and sent to the second module. In our second module we will upload data on ThingSpeak server so we can monitor is wisely, and we alert a user the real-time weather condition. So here are the technologies. In hardware part we are using node MCU, DST11 sensor and breadboard. In software part we are using Arduino IDE and ThingSpeak server, and use libraries like ESP8266 Wi-Fi, DST for temperature monitoring, and languages such as C, C++, HTML, CSS, JavaScript. We will use HTML, CSS, JavaScript in our further part when we are developed our website completely. So here are the implementation part. In implementation part, first we are look at the virtual. In virtual collection, First we are look at the node MCU. In node MCU, here we are connecting the 3.3 volt pin to the DST11 sensor of VCC, and GND of node MCU pin connected to the GND of DST11 sensor, and the data output pin of DST11 sensor to the GP input output 0. Here we are completing our virtual part. Now you can look at the real part, which is we are actually implemented. So this is the node MCU and this is the DST11 sensor, and here is our breadboard, and here we are connections. After implementation, first we are showing the data analytics, that is data visualization, and numerical value generator and alert lamp. So I will explain you what actual software implemented we are. So after proper connection to our hardware device, we will get output like this. So here our temperature in degree Celsius and humidity in percentage, which is sending a data to our server, that is ThingSpeaks. So now we will see how actual data generated. So for this one we will opening our ThingSpeaks server. So first of all, after the authentic sign in, we will get actual data. So if person is authenticated, so he can actually use this handle. So here our data generation. So you can see this is the data analytics which is generated from this port. You can see we will get exact readings. We will get the exact reading where I kept this hardware device. So now actual temperature of my room is 34 degrees Celsius and actual humidity is 47%. So you can see this is the temperature and this is the humidity. And now extra feature which I earlier mentioned, that the alert lamp. How this alert lamp works? For example, consider in my room I have kept sacks of rice. So we know that actually rice needed below 35 degrees Celsius temperature and below 60% of humidity. So if the temperature rises above 35 degrees Celsius, above or equal to 35 degrees Celsius, so here it will glow this alert lamp, means this lamp will glow. And if humidity is crosses over 60 degree or equal to 60 degree, so here humidity lamp will be glow. And we can also see this is the analytics which are generated now. And after that, if we require this data, so we can export data in the form of .xml, .json or .csv, that is comma separated value. So here is our autoclimate monitoring system. Software testing. We are tested hardware components connections of node MCU and DST11 sensors on breadboard. We are tested a port of device to transfer the real-time data to ThingSpeaks servers. We have tested a user interface module which is temperature and humidity numeric value generator, data visualization and alert lamp. Now applications. This system is used to monitor the warehouses containing agriculture goods, dairy products, etc. This system is useful for farmers, also used for industrial purposes. Also in big cities we can monitor pollution, and also we are using this system to weather forecasting. Now conclusion. We developed the web application for auto climate monitoring system which fulfills following needs. Low cost solution for auto climate monitoring system so user can install as much as possible devices, accurate real-time data generations and showing appropriate data visualizations. User-friendly features like alert lamp. Here we are references.